Okay, so we have already talked about tests to see if a quadrilateral is a parallelogram. So we're going to continue with some examples. So we're going to call this example 2. And I'm going to go ahead and just draw my quadrilateral. And I'm checking to see if it is a parallelogram. So I have A at the order pair of -3 and 0. B at the order pair of -3, 4. C at the ordered pair of 3 and -1, and D at the ordered pair of 3 and -5. So sometimes you'll have directions that specifically say, prove this is or is not a parallelogram by using the distance formula. So if we go back to the last set of notes that we had, I'm going to grab this one instead. If I'm supposed to use just the distance formula, that means I'm using this. So I am trying to prove that both pairs of sides are congruent. If the directions say, hey, we want you to use the distance formula and the slope formula, then this is what you would actually be proving. Okay, so for this one, I'm going to put that we are trying to prove are both pairs of opposite sides congruent. And I'm going to put a question mark there because that's what I'm trying to prove. I don't know if they're congruent yet. That's what I got to prove. So I'm going to find the distance of, or the length of AB. So I have the square root of a -3 minus a -3 squared plus 0 minus 4 squared. Minus a negative is plus a positive, so that gives me 0 squared. And I get -4 squared. And that gets me 0 plus 16. So AB is the square root of 16, which is 4. Okay, so I have AB is 4. I like to do the opposite side of, so it would be CD. That way, if these two are not the same length, then I'm done. I don't have to do any more work. So CD, we'll find the distance for the length of CD. So the square root of 3 minus 3 squared plus -5 minus a -1. 3 minus 3, there's my 0. Minus a negative is plus a positive. So I have -4 squared. And I'm right back. The CD equaling the square root of 16, which is 4. We're not done yet. So we have the fact that those are congruent. So AB is congruent to CD. So I could go up to my diagram and put some tick marks there. But now I got to prove the other pair. Some of these might have some little lengthy work. So if I look at AD, I have the square root, -3 minus 3 squared plus 0 minus a -5 squared. -3 minus 3 gives me a -6 squared. Minus a negative is plus a positive. So I get 36 plus 25. So AD equals the square root of 61. I'm not concerned with the decimal value, so I'm going to go ahead and just leave it like that. But I have one more segment that I have to check out. So I need to find the length of BC. So BC equals the square root of -3 minus 3 squared plus 4 minus a -1 squared. -3 minus 3 gives me a -6 squared. Minus a negative is plus a positive, so I get 5 squared. Right back to 36 plus 25, so BC equals the square root of 61. Okay, so what I want you to notice is, notice I didn't just put a D, 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 and a D for distance on all of these. I can clearly see what measurement each segment has. So that's going to be important with your work because these get a little bit hairy when it comes time to grade. So I have already noted that AB is congruent to CD. I can also note that AD is congruent to BC because they have the same length. So going back up to my diagram, I can put tick marks there. Now I have not answered the question yet, and that is this a parallelogram? So I'm going to say, yes, ABCD is a parallelogram because, this is the important piece, oopsie, both pairs of opposite sides are congruent. So not only do you have to show the work, you have to justify why you are saying, yes, it's a parallelogram, or no, why it's not a parallelogram. So there's another example.